And the next stop in our fun-filled tour through TICCIT Math is a fabulous function factory. If you'll just step right this way, we'll find out the facts so you too may fashion fantastic functions and fathom their innermost secrets. Here's where the raw material for the function factory comes in, folks. We get those ordered pairs from the unit on relations. You will remember that a relation is a set of ordered pairs where the first element comes from the domain and the second element comes from the range. They are tied together by the rule of correspondence. A function is a special kind of relation. While some relations will allow one element of the domain to be paired with more than one element of the range, a function will allow one element of the domain to be paired with one and only one element of the range. As is the case with other relations, functions may be shown in roster, graph, or set notation. In roster form, it's easy to tell if a relation is a function. Each element in the domain is paired with only one element of the range. All elements in the domain must be different. If two elements are the same, then this element is paired with more than one element in the range. Here, 7 is paired with 10, and also with 6. In this case, it is not a function. Likewise, this graph is the graph of a function, since for every element in the domain, there is one and only one element in the range. This is not the graph of a function. Generally, set notation is not used with functions. Instead, we use functional notation. In functional notation, we usually give the function a name, like f. And for any value x in the domain, there is a unique value, f of x, in the range. If we have an element x in the domain, like 2, the f of x stands for the corresponding element, in this case, 6. Sometimes there is a rule like an equation. We can give the second element in terms of the first. This tells us all about the function f. Given any element in the domain, we can compute the corresponding element in the range using the equation. If a function is described with an equation, we say it is given in functional notation. A function is like a machine. It has 3 parts: a domain, a range, and a rule of correspondence. You can look at a function like a machine which takes elements in the domain and changes them to elements in the range. Of course, there are many different types of functions. For instance, there are even functions where you can put in either x or negative x and come out with the same number. And there are odd functions where if you put in x, out will come a number, but if you put in negative x, out will come the negative of that number. Then some functions have an inverse function. What the one function does, the other undoes. Functions which can be undone are called one-to-one functions. And if we have a one-to-one function, g, the function that undoes it is called the inverse of g. Notice that the domain of g is the range of g to the negative 1, and vice versa. Of course, g is also the inverse of g to the minus 1. They are both one-to-one functions. They are inverses of each other. Not all functions have inverses. Look at h of x equals x squared. It contains the pairs 2, 4, and negative 2, 4. If there is an inverse function, it must undo the number 4. That is, it must turn 4 back into the numbers which made it in the first place. But if it does that, it has produced 2 different elements of the range for one element of the domain. H inverse is not a function. It is only a relation. This unit will show you how to tell if a function is one-to-one and how to build inverses. But you'll have to take that lesson later. Now, there are a whole batch of tricks you can do with 2 or more functions which have the same domain. You can add functions, subtract them, multiply them, or divide them. And then there is the composition of functions, where we sort of bolt 2 functions together so that f feeds into g. This will work as long as the range of f, its output, is part of the domain of G. It's input. Look, suppose we take two functions in roster form. Notice that every element of the range of f is a member of the domain of G. So therefore, G of f of x will work. But notice that it won't always work the other way. In G, 3 produces 2. But there is no 2 in the domain of f. You can't hook them up this way. The new function you get by putting two functions f and g together, one after the other, is called the composition of f and g. And you guessed it, you can learn all about it in the unit. Oh, you're going to like this unit. Just look at the many applications of functions. Hope you enjoyed our brief tour. You're now free to wander the rooms and hallways of the fabulous Function Factory via your TICCIT television and keyboard as you begin the unit on functions.